light does indeed have a brain. It wants to choose the shortest path. Now, obviously, it doesn't literally have a brain, but this is what's known as the path of least action. It always wants to take the shortest distance. All right, well, that's it, I guess. Did any of you learn anything from that? Hopefully you did. Oh.
Nice to meet you.
Oh, nice to meet you too.
You remember me?
Oh, no,
Aham.
I don't think I do.
Aham, from the Toastmasters. Like I interviewed you once.
Oh, wow.
In an event in Kerala.
Oh.
Through Zoom.
Nice to meet you in person. I'm sorry, I need to stay hydrated.
In Einstein's formula, E is equal to mc square, where c is the speed of light. So how does the speed of light influence the potential energy of an object? Is it just a constant or it's correct in a way?
Einstein's equation E equals mc squared shows that energy and mass are two forms of the same thing, mass energy. In a nuclear reaction, mass decreases and other types of energy increase. The sum of mass and energy is always conserved in a nuclear reaction.
Two balls collide while traveling in opposite direction and start sticking together like wads of gum. Will the mass of the two balls combined change?
Well, you have to consider that if they stick, some kinetic energy must have been lost. But where does that energy go? Well, it might leave through sound or heat, but let's assume that we are in a vacuum where sound cannot exist. So it gets converted into mass with the equation E equals mc squared.
Is mass conserved in E is equals to mc square at a chemical reaction?
Mass? I'm pretty sure it's not conserved in a chemical reaction. The fundamental conservation law of the universe is the conservation of mass energy, not mass. That means that the sum of the total mass and energy before a reaction in a closed system that doesn't interact with anything in its environment equals the total mass and energy after the reaction. According to Einstein's famous equation, E equals mc squared, mass can be transformed into energy and energy can be transformed back into mass. This isn't some exotic process, but in fact happens every time there is a reaction. Mass is therefore never conserved.
Now consider a lamp. This lamp gives off light. We keep this lamp powered for a long enough time. It's going to disappear. How long will it take a 60-watt bulb with a mass of 50 grams to disappear?
Well, to find out how long it will take, first we have to know the wattage. So that's the amount of joules per second put into light, or the power. Usually they tell you that on the package. Then you have to find the mass of the lamp. We have to convert that mass into joules with E equals mc squared, and then divide it by the wattage to find the amount of time in seconds it will take. However, this takes a very long amount of time, like millions of years.
Okay, thank you, Professor.